For our last example here, we want to compare annual percentage yield versus annual percentage rate. So the yield is the rate with compounding, so it's including any compounding inside of a year. But the annual percentage rate is the rate without compounding. So if you want to figure what your annual percentage yield is, what you can do is you can take your PV to be equal to 1. And then for 1 year, then N is just going to equal M. So then your future value of $1 for 1 year is going to be, there's actually a 1 out here for your PV, and then 1 plus R to the N is M, and that's just equal to 1 plus R to the M. So that's your future value. And then your APY is going to be the interest earned on $1. So you take your future value, subtract off the present. Well, here's your future value from right there, and subtract off the $1 you started with. So this right here, that's your APY. And remember, R is APR divided by M. So that is this formula right here, which you can write like this if you want to sub for your R, APR divided by M. And then if you take this formula and you algebraically solve for APR, you'll get this one. So if you're given APR, you can find APY, and if you're given APY, you can plug in and get APR. And then just a note here, if M equals 1, if you've just got one period, there is no compounding. APR and APY will be the same thing. So let's look at an example here. So we've got two banks here. Mega Bank advertises a CD with an annual yield of 1.58%, monthly compounding. And eSave advertises a 1.5% APR with daily compounding. And we want to know which one's better. So, well, we can either convert this APY to an APR, so we're comparing two APRs, but it's a little hard to tell without, the compounding being figured in. So we really would like to take this 1.5% APR and change it to APY. So let's see, let's actually do both ways. We'll get practice with both formulas. So for Mega Bank here, M is monthly compounding here, so M is equal to 12. And then the APY they gave us was 1.58%, 0.0158. So here's our formula for APR from APY. So we're going to take M is equal to 12, and we are going to multiply that by 1 plus the APY to the 1/12th power. So this will be 1 plus, and our APY 0.0158. And then we do a 1 divided by 12, 1/12th power. And then we need to subtract 1 inside the parentheses. That whole thing gets multiplied by 12. And so let's see, we got scientific notation is going to be 0.01568. And take that guy off. So 0.15686. So if we keep same number of decimal places, this would be 0.157. So it's 0.0157, 1.57% APR. And that's with monthly compounding. So we want to know, is 1.57% compounded monthly better than 1.5% compounded daily? So more compounding, remember, increases your value quicker. So is it better to have a little higher rate with less compounding or a smaller rate with more compounding? Okay, still can't tell at this point, but we got some practice changing to APR. Well, let's take the 1.5% and figure the yield, because then we'll be compared both things with compounding. For the eSave account, we're doing daily compounding, so M is 365. And so then your APR they gave us was 0.015, 1.5%. So now let's go ahead and plug in here. So we are going to do 1 plus, and we'll do our 0.015. And then we're dividing by 365. And then we're going to do a 365 power and subtract 1. Let's go ahead and compute there. So again, scientific notation, I'm going to move the decimal to the left 2 places. So 0.01511. So that's 1.51. So 1.51%, and that's APY. So the eSave is 1.51% APY, and the Megabank is 1.58% APY. So we're comparing two APYs. They both take in the different rates of compounding in consideration. So the Megabank is better. And then just a note here, take a look at the example that is in your printed notes. Notice here we figure the APY here for 7% and compounded quarterly, monthly, and daily. So if you do quarterly here, you get an APY of 7.186. If you do monthly compounding, so more often compounded, we get 7.229, a little bit bigger. And then if you do daily compounding, you get 7.25%. So we're just plugging into the same formula, just changing our value of M. So notice that our APY goes up with more compounding. Okay, so that's true in general. So the question is, how much does it go up? Well, here from quarterly compounding to daily, it only went up 0.07%. So the APY should be bigger than the APR, but from 1.75%, well, I guess it's 7% to 7.25%. So the APY was 0.25% higher. So, and that's about right, 0.1 to 0.2, 0.3, maybe at the most higher. So if you get an APY that's a whole percentage higher than the APR, probably you did something wrong there. And then let's also just take a look over example 6 here. So we're given an APY of 6.66% here, and then we're determining the APR for different compounding periods. So if you do quarterly compounding, so that's plugging in the same formula we used with M equal 4, we get 6.5% APR. If you compound monthly, you only need 6.46% APR to give you the same yield. If you compound daily, you only need 6.45% to give that yield. Again, notice the APR is less than the APY, and if you have more compounding, your APR decreases for the same APY.